Hi everyone, this is Functional Groups Part 2. We're looking at the next 4 functional groups, so groups 5 to 8. Our first one is a carboxylic acid, and I can see that the program has messed this up. Let me draw it down here for us. We've got R for any carbon chain length, C, double bond O, and OH. Just ignore this hot mess up here. And this part is called a carboxyl group. So it's kind of a hybrid between carbonyl, which we've seen before, and hydroxy, which we've seen before as well. The properties and uses of carboxylic acids is just like the name suggests. They are weak acids, so we find them in everyday substances like citric acid, so they're found in fruit and fruit juices, aspirin. Also when your muscles get sore, that's lactic acid that's building up in those, so lots of everyday things. Their naming rules are that we're going to change the ane ending. We're going to take the E off and put oic acid on instead. Also, this, because it's a functional group, just like the other functional groups, it gets the lowest number in the parent chain. And it's always the end of a chain, so no matter where this functional group is, whether it's the far left or far right of a carbon chain, that now becomes your number 1 carbon, and then you number from there. Any substituents we would name as we normally do. So let's try a couple of these on for size. So our first one here is 5-ethyl heptanoic acid. So we're going to start with hept. We're going to start with the parent chain as always. So 7 carbons, 1, 2, 3, 4, 5, 6, and 7. Now, it doesn't really matter where we put the oic acid. That's the part we're going to do next, though. This means double bond OH. Let me just write this a little bit prettier. Let's go yellow. So C double bond O, OH, that's what oic acid tells us. So we can either put that on the first carbon on the left or the last carbon on the right. Because it's sort of set up to go to the right, I often will draw this on the right. But if we did it on the left, I would just put the OH sticking out to the left instead of to the right. I'll show you another example of that in a moment. And then number 5 ethyl, so our substituent is on the number 5 location, and ethyl is a 2-carbon chain. When we're numbering, we have to number from that carbon that's part of the functional group. That's the most important carbon now. So there's your number 1, 2, 3, 4, and 5. So that's where you'll put your ethyl, your 2-carbon chain, and then after that you're just putting in H's. The one down below, I will just re-emphasize that this bond here is a carbon there, and it's a double bond OH. So again, we have that functional group. So this one is called a benzoic acid. This is just sort of a common name for this one. Why can't I make dots? So this is just a common name one where you have a benzene chain and then you have the functional group coming off of one of the corners in the benzene chain. Just like we've seen before, if I tried to put the functional group on a corner instead of making it come off, the problem here is that I have way too many bonds at that point. So I have to make an extension to put that functional group on. So this is what I meant before about if you draw the OH on the left versus the right. So for instance, if I had a 3-carbon chain, if I wanted to put the carboxyl group here, I would just flip the OH. And if I wanted to put it here, I would keep it the same. Now, if you didn't flip your OH, this just shows that the C is connected to the O, not the H. So a common thing that I sometimes see is this. I'm not going to be that picky, but this is a more proper way to do things. All right, the next one that we're going to do is esters, and esters are made up of 2 functional groups. So we can sort of see them here. We've got a carbonyl group again, and we've also got an ester group. So we have 2 carbon chains. We have the carbon chain that involves the double bond O, and then we have the carbon chain next to an O. Both of these halves will get their own names as we'll see. So esters generally have pleasant smells. I say generally because we've actually created these artificially in the lab before. Usually the ones that we do in the lab, we do banana, and that one usually turns out pretty well actually. We also do peppermint, which is really good. That one usually always turns out. And then we also do cherry. And cherry is sort of Think of like cherry in the form of like medicine. I used to have cherry medicine as a kid, cough medicine. It tasted revolting and it didn't smell that much better. That's kind of the cherry that we end up making in the lab. But I will tell you, one time we made pineapple because I love pineapple. And it was the worst experiment of our lives. It was so terrible. It smelled like dead people and feet. It was revolting. And I stunk up the entire science wing, like the entire place. We practically had to shut things down. It was so terrible. Whoops-a-daisies. So the naming rules for these ones, as I mentioned, we name in two halves. So there's a carbon attached to an O, that's one half. This one gets named last. So whether I draw it on the left or the right, I still name it last. Its ending is an O8. On the other side, I've got this carbon chain next to the O. And this guy gets named first, and it gets a YL ending. So think of it like a substituent because it's got that YL ending that we've seen before. The biggest change with this one is that there's actually a space between the names. So we never see a space between words. Words usually string into other words, but esters, usually we have a space between the names. Let's try some on for size. So here's our first example, and again we have our two carbon chains. So the first one that I'm going to identify or just put a box around is the one that has the double bond O. The second one is the one next to the O. This one is the one that gets named first. This one gets named second. This one gets an O8 ending, and this one gets a YL ending. So when we put it all together, we have a one carbon chain to start. One carbon here, so we have a methyl, then we have a space, and now we have a three carbon chain over here, so we have a propanoate. So propane, remember all we do is we get rid of the E, so I'll get rid of the E, and I'm going to put my new ending on O8. So methyl propanoate. Let's try another. So let's draw an ethyl butanoate. There's a couple of ways we can do this. I usually start from the left and then I start drawing. So we know that ethyl is two carbons, so I would draw my two carbons. I need to be able to make sure I recognize this functional group. So we're going to be making flashcards in the next little bit, and part of the flashcards is recognizing that YL space O8 equals this functional group. That's going to be part of getting that into our heads, and knowing that the YL part is next to the O. So I would put that part in first. Now I'm dealing with a butanoate. So this is a four carbon chain, 1, 2, 3, 4, based on but, and the double bond O has to be next to the O. So this whole grouping, O double bond O, has to be together. Then I'm just putting in H's. Another technique is actually to start with the functional group, and you can draw it with the O on the left or the right, it doesn't matter to me, and then put in the two carbon chains. So ethyl is the one that goes next to the O, so we'll put it over there. Butanoate is the one that includes the double bond O. So I've already got one of four, I've got to add three more, and then again putting in my H's. So a couple of different techniques there. The seventh functional group, we're going to switch gears a bit. We are going to get into amines, and amines have a nitrogen in them. So a nitrogen group is attached to a carbon chain, and we can change things up here as well. So the H here and the H here could be replaced by carbon chains. So they can be very simple amines, or they can be more complicated. Because of this, we can have primary, which is actually written like this, or secondary, or tertiary. I'm going to show you some examples. So here are three different amines, and I've tried to make them pretty similar. The N doesn't have to be on the second carbon, but I've just again made it something that looks very similar throughout, and I'm going to ask you to figure out who is the primary amine, the secondary amine, and the tertiary amine. This one's actually a little bit even easier than the alcohols, I think. So it has to do with how many carbons the nitrogen's bonded to. So if the nitrogen is bonded to only one carbon, we have a primary amine. If the nitrogen is bonded to three carbons, like in this case, we have a tertiary amine. And if the nitrogen is bonded to two carbons, in this case, that's a secondary amine. Amines are not particularly nice. They are usually stinky things like dead fish odors. There's ones called putrescine, cadaverine. They're pretty nasty things. They're on page 69 if you want to see some examples. And we're going to have a look at how to name them. So this is the only functional group where we actually put a prefix on the parent. Most of the time we're changing the parent ending. This time we change the beginning of the parent. So we'll keep the parent name with the number of carbons as usual and an ane ending. So for instance, a pentane. But if there's a nitrogen on the pentane, I would call it an aminopentane. So it's a prefix. As per usual, we're going to number in front of the parent chain, in front of the amino part of the parent chain to say where the amino is. Then N could go in the first location, but could also go anywhere on the chain. If there are carbons on the N, we put an N in front of the name of the substituent, and I'll show you some examples to get an idea, because this part is the trickiest. But once you've sort of seen it in play, you'll kind of get the hang of it. So I'll show you some progressively more challenging examples here. So we're going to start off easy. This one is just a 2-amino butane. So as usual, we're going to start with butane. 1, 2, 3, and 4. Now we're going to put an amino on the number 2 location. So here is our number 2. And amino just means an N. Now we're putting H's in. There's nothing else on this other than H's. One thing you'll want to make a note of here, and you would have seen it in the general examples, is that nitrogen, if we think of what its Lewis structure looks like, I'm going to put it up here. It has 5 valence electrons. It only needs to make 3 bonds. So 3 bonds only. We're so accustomed to doing 4 bonds because of carbon that sometimes we make mistakes here. So we're going to do CH3, CH, H2H3, and you can put the ends together like this, or you could draw them out like this. Either way is totally fine. Let's get progressively more difficult. Again, starting with our parent chain. Let's start with pentane. 1, 2, 3, 4, 5. Now we're going to put on our amino in the 3rd location. I'm going to number from the left. My amino is just an N, so when we see amino, that just means nitrogen. Now we're going to do an N-methyl. An N-methyl here just means to put a 1-carbon chain on the N. So that tells me to put that there. After that, I'm putting in H's. I should have paused so you didn't have to see this painfulness. Again, watching that N only has 1 bond. All right, this is the hardest of the bunch. I would recommend you pause and try this one on your own, and then check to see if you got it correct. So I'm going to start taking it up, so pause now if you want to do so. Otherwise, keep listening. We are starting with butane, so starting with 4. 1, 2, 3, and 4. Now we're doing 2-amino. Amino just means the N. 2 tells me to put the N on the number 2 carbon of the parent chain. Now let's work out these substituents. So I've got something that says N-ethyl. Ethyl is a 2-carbon chain. N in front means put that ethyl on the nitrogen. 1 and 2. Let's go to this one. I've got an N and a 3 dimethyl. Di means times 2. Methyl means 1 carbon big. And I'm going to put one of them on the N and one of them in the number 3 location. The 3 refers to the parent chain. So on the other side of the N will be my 1 carbon, and on the 3rd carbon of the parent chain will be my other methyl. Now I'm putting in H's. And there we have it. That's about as complicated as they get. Now that we've learned this sort of N notation to tell us if there's stuff on the N, it makes our last functional group a little more easy. They're called the amides, and you'll notice they too also have these N's, and just like the amines, the H's can be replaced by carbon chains. So this is a larger functional group. We have a C double bond O, which we've seen before, or carbonyl, attached to that N. So there's our functional group there. And these are the backbone in larger molecules like DNA and proteins, but they can also be found in things like DEET for getting rid of insects, and some Tylenol. So that's how that one works. The naming rules are really simple. The parent chain gets an amide ending. So we take our ane ending, we get rid of the E, we put amide on. The carbon chains on the N are named the same way as the amines, as I mentioned before. So if there's a methyl on the N, we would call it N-methyl to say that methyl is on the N. Let's do some examples. Let's start with a simple one. Let's make a propanamide. So again, starting with the parent, we've got 3 carbons. 1, 2, 3. And then our amide is that double bonded O on the end, attaching to an N. Because there's no other fanciness about this name, it's time to put in H's at this point. And again, typically on the end we spread the H's out, but you could tuck them in and make them an NH2 as well. Totally fine. Let's try another. So let's name this one. Again, we're going to start with that carbon chain. So there's the focal point there. And because there are 4 carbons, we would call this a whoops, I'm going to need more space. Move over. Butane. Now I'm going to get rid of the E, and I'm going to put amide on. So it's becoming butanamide. And now I want to say that there's this 2-carbon chain, and ethyl, hanging off the N. I don't have to say anything about the H. The H is going at the end as always, but if there's something fancy, I do have to say. So out in front, I'm going to say N-ethyl, and there doesn't need to be a space. So you'll notice I've just sort of cheated there, and I've just said N-ethyl butanamide. All right, time to get some practice in. The homework is in sections. So the first one's the carboxylic acids. Second one is, what was the second one today? I can't remember. Anyways, they're all in sections. So it keeps it simple because they're all going to be very similar. But there are some tricky ones in there. So do all of them and then request the homework and we'll take it up from there.